Welcome to AiCE Work 2022. This program is designed to give prospective students a taste of what it is like to study in AiCE while helping them to develop important AI and computer engineering skills and to have fun learning. Regarding the competencies, students will have to choose 3 out of 5 competencies. And what are 5 competencies that be offered in our AiCE Warp? Number 1. AI applications in computer vision. Instructor, Dr. 𝐀𝐢𝐂𝐄 𝐖𝐚𝐫𝐩. As one of the major driving forces in modern AI adoption, computer vision has a wide range of applications, from high-speed inspection on a manufacturing line to the face unlocking feature from your mobile phone. We'll explore how AI can be used to help computers see and perform various tasks on images or video streams. You'll learn about fundamental concepts of computer vision, including basic image representations, manipulation, and filtering. Through a series of hands-on exercises, you'll learn about basic neural networks and deep learning concepts that can be used to solve computer vision tasks. You'll also learn about the tools such as PyTorch that can be used to build or train your deep learning model and applications. Number 2. Computer systems. Instructor, Dr. 𝐀𝐢𝐂𝐂𝐄 𝐖𝐚𝐫𝐩. Software that does not exist in isolation. It is always running on hardware, processors, and interfacing with external components, touch screens, buttons, motors, etc. This competency aims to develop skills in interfacing between hardware and software. In this competency, you will learn how software that you develop, code, is actually executed by the hardware processors. To do this, we will use a mini-computer board that is connected to peripheral devices, buttons, joysticks, LED. You will see, for example, how software can detect that a button has been pressed and how software can turn on a light in response. We will start from basic examples where you have a very hands-on experience and use this experience to help you understand how something as complex as a laptop or a smartphone is actually built and works. In the broader context, this competency shows how engineers integrate several different hardware components into a unified product that can run application software. Specific activities. Set up a programming environment, compiler, loader, for a computer board design and implement software that acts on the board's outputs, for example, LED. Design and implement software that reacts to board inputs, for example, user buttons. Implement computer systems that operate in precise timing requirements, for example, do something precisely every second. Number 3. Data structures. Instructor, Dr. Sally Golden. To create software that can solve practical problems, we need to consider both the calculation methods and logic, algorithms, and the information involved in these calculations. In the data structures competency, you'll learn about methods for organizing information in real-world software so that it can be processed quickly and efficiently. For instance, how do you think YouTube finds videos for you about a particular topic? With many billions of options available, you can be sure it's not by looking at every video on the platform one at a time. We will look at the basic concepts of a few key data structure categories, including lists, objects, trees, and graphs, using simple examples to illustrate how these structures can be created and used. You'll also get some idea of what kinds of problems can be solved with these structures. In the hands-on lab exercises, you'll work with existing programs in several programming languages to explore and to modify their behavior. If you do not have any experience with programming, this is a great way to get an introduction, since you will only need to write a small amount of code. Students who have more advanced programming skills can choose to write programs using these data structures from scratch. Number 4. Immersive Environments. Instructor, Dr. 𝐀𝐢𝐂𝐄 𝐖𝐚𝐫𝐩. Immersive environments are situations in which computer-generated images and other stimuli are combined with the experience of the real world. Depending upon the amount of real versus generated material, the results can be labeled as augmented reality, AR, mixed reality, MR, or virtual reality, VR. AR/VR is one of the core technologies behind the concept of the metaverse. In this competency, you will have the opportunity to learn about the basics of immersive environments and how to get started creating content and designing interactions, followed by deployment on mobile devices and headsets. We will be using Unity 3D, which is the most popular platform for developing games and creating mixed reality applications and experiences for current and next-generation devices. Unity 3D will allow you to develop mobile apps that can augment the physical world with meaningful visual content, such as adding imaginary buildings to the campus, for the purposes of exploration, expression, experimentation, commentary, or just pure fun. This competency is intended to give you a little taste of the knowledge and skills involved in a full study of IE and to help you understand why this competency, in its full format, is one of the most fascinating and practical subjects you can study. The lectures will consist of engaging discussions on the fundamental concepts of immersive environments, followed by labs that will consist of hands-on work, creating a fun little program in Unity 3D that can then be used with smartphones and headsets. Number 5. Introduction to Machine Learning. Instructor, Dr. Sally Goldman. Introduction to Machine Learning, ML, will introduce the core concepts you'll need to understand and build ML systems. Computer systems that can learn patterns from data, then use those learned patterns to make predictions about previously unseen items of information, or identify those items as examples of a particular category. In particular, we will focus on the difference between so-called supervised and unsupervised learning methods. The main difference between these two categories is whether you know ahead of time what the answer should be for a particular item of data used to teach the ML system. In the hands-on lab exercises, you'll work in teams to create example datasets. Then you will use both your own data and datasets available on the web to implement simple supervised and unsupervised ML systems. The labs will introduce you to several popular ML software frameworks, including scikit-learn and Weka. What competencies will you choose? We look forward to welcoming you to the WARP experience on the 20th of June.